In 2026, every quote-unquote AI startup right now is actually an operating system. They're a thin layer of UX on top of a kernel, the model, that they don't own and can't see inside. When the kernel goes down, your app goes down. When the kernel hallucinates, your app lies to customers. When the kernel changes its behavior on a Tuesday, your app silently breaks for everyone. 1/9 of uptime means the kernel is unavailable for 36 days a year. Postgres typically runs at 4 nines. AWS S3 at 5. Cloudflare Global Network over 5. We are running production businesses on top of a substrate that is between 1,000 and 10,000 times less reliable than the substrate underneath everything else we ship. We are pretending that's normal. This isn't a complaint about Anthropic. OpenAI is no better. Google is no better. The entire frontier is operating at a reliability tier that would get a regular SaaS company fired by their first enterprise customer. Pull up the Anthropic status page. Look at the last 6 months. Count the orange bars. Elevated error rates, increased latency, degraded performance on Sonnet, degraded performance on Opus. This is the recurring weekly headline. Now do the same with OpenAI. Same picture. ChatGPT down. API errors. Rate limit instability. The pattern is identical because the underlying constraint is the same. GPU capacity is bottlenecked, models are too large, demand outpaces. The builder community has known this for a year. Look at any Discord, any Twitter timeline, any Hacker News thread on a Tuesday afternoon. The phrase Claude is being slow is more common than good morning. But here's what makes this different from a normal cloud outage. The dominant failure mode isn't downtime, it's degradation. The model is up, but it's slower, dumber, or differently wrong than it was yesterday. An API endpoint that returns a 500 is debuggable. An API endpoint that returns a confident, plausible, completely wrong answer is not. That's the new failure mode the industry hasn't built tools for. If you came up through traditional infrastructure, your reflex when something is unreliable is retries, failover, caching, circuit breakers. None of those work here. Retries don't help when the model gave you a syntactically valid but semantically wrong response. The retry just costs you twice and gives you a different wrong answer. Now, you have 2 wrong answers and no way to pick. Failover doesn't help when there is no second kernel with the same capabilities. Switching from Claude to GPT mid-workflow means the system prompt no longer applies. The tool schemas might be incompatible. The output style changes. It's not failover. It's a re-platform. Caching doesn't help because the same input doesn't deterministically produce the same output. Cache hits return last week's wrong answer instead of this week's wrong answer. The standard ops playbook was written for systems that fail loudly, deterministically, and locally. AI systems fail quietly, probabilistically, and globally. Different problem. Needs a different playbook. Which is why the harness matters more than the model. The harness, the thing wrapping the model, is where reliability lives. The model can't be made reliable. The harness can. Think of it like an operating system. The kernel is the model. The shell is the prompt. Syscalls are tool use. Permissions are safety. The package manager is MCP, the package manager. That last one matters more than people realize. When you stop choosing a model and start building a stack, your reliability stops being whatever Anthropic's reliability happens to be on a given Tuesday. It becomes whatever your stack's reliability is. That's a shift you control. And that's the bridge to everything else worth building right now. Routing layers, skill registries, agent harnesses. They are not features. They are the reliability layer the kernel can't provide. If you only remember one thing from this video, reliability is not a property of the model. It's a property of the system around the model. Build the system. Concrete picture of what reliability looks like at the harness layer. Multi-model routing, so when Claude is degraded, the same workflow falls through to GPT with translated prompts, not blind retries. Local fallback for deterministic operations. If you're calling a model just to run a regex, you don't need a model. The harness should know that and route around the model entirely. Receipts on disk for replay. Every model call should be logged with full inputs, full outputs, and the model version used. When a customer reports something broke last Thursday, you can replay it bit for bit and see what changed. Schema validation on every output. If the model returns malformed JSON, the harness, not the user, catches it, asks for a fix, and only commits a valid result downstream. The customer should never see a hallucinated tool call. These 4 things, routing, local bypass, replay logs, schema validation, are not advanced features. They are the table stakes for shipping AI in production. The harness is the reliability layer. Everything above it inherits its reliability. The frontier labs are still chasing capability. They will keep shipping models that are smarter than last quarter's models. Capability is not the bottleneck. The bottleneck is the kernel being so unreliable that you can't durably build on it. Until the labs reach 4 nines, the entire industry is building on Quicksand. The harness is the only thing that can dry it out. That's where the leverage is in 2026, not in picking a model, in building the stack. Next video in this series, the OS layers most people don't see. Kernel, shell, syscalls, package manager, and where each one is being built right now in 2026. Subscribe so you don't miss it.